This is Lesson 1-8 from the Algebra Readiness textbook. Today's learning target is to use patterns to solve problems. So what do songs on the radio, computer code, and your body's DNA have in common? All of these are based on patterns. Radio uses patterns of electromagnetic waves. Computer code consists of patterns of numbers. And your DNA? Well, it's made up of molecules that repeat in special patterns. You can actually solve many types of problems by finding and using patterns. Making predictions from patterns is a form of inductive reasoning. Let's do an example. News spreads quickly at STMA Middle School West. Each student who hears a story repeats it 15 minutes later to two students who have not yet heard it. And then that person will tell no one else. Suppose that one student hears a news at 8 a.m. How many students will know the news at 9 a.m.? Now, it's always best when you're doing a word problem to read it at least twice. So let's read it one more time. News spreads quickly at STMA Middle School West. Each student who hears a story repeats it 15 minutes later to two students who have not yet heard it, and then tells no one else. Suppose one student hears the news at 8 a.m. How many students will know the news at 9 a.m.? Let's make sure that we have a full understanding of what's happening. How many new students will hear the story at 8:15? So one person knew it at 8. So 15 minutes later, how many new students? Well, each student repeats it to two new students. So the number of 15 minutes later. So that means that at 8:15, it would make sense that two new students have heard it. Now, how many 15-minute periods are there between 8 and 9 a.m.? The reason that's important is because the question asks us how many students will know the news at 9 a.m. It's easiest to organize our thinking in a table. So we're talking about time, and the starting time is 8 a.m. And we're talking about new students who find out and total students. So at 8 a.m., one student knows, so a total of 1. Now every 15 minutes, each previous student will tell 2 students. So there was one student who knew. 15 minutes later, that student told 2 more. Now the total number of students who know are the one who told plus the 2 new ones. So 3 total. Then it's not 8:15, now it's 8:30. Now remember, only the new students are going to tell 2 more each. So if these 2 students tell 2 more students, now 4 students know. The total number of students who now know are the 3 from before plus the 4 new students, so 7 total students. Then at 8:45, 15 minutes later, each of these previous 4 students are going to tell 2 more each, and so now 8 students know. The total number of students who now know are 8 students plus the previous 7, and that's a total of 15. 15 minutes later, it's 9 a.m. At 9 a.m., these 8 students are now going to tell 2 more students each, and so now we have 16 additional students who know the news story. Now we had 15 who knew, plus the 16 who just found out, for a total of 31 students. 31 students will know at 9 a.m. Some people like to use a table like this. Let me show you. Each dot represents a person. We started off with one person at 8 a.m. knowing the story. Then that person told 2 people. So now all 3 of these people know the story. Now each of these 2 told 2, and each of these 4 told 2, and then each of those 8 told 2, and you can see how it just grows and grows and grows in a tree diagram. So far that at 9 o'clock, 31 students know. So now how many can you continue the pattern? If I had just given you the table, could you continue the pattern and find out how many students will know at 9:15? Well, let's look at the pattern here. How do I get from 1 to 2, from 2 to 4, from 4 to 8, from 8 to 16? It looks like this column is multiplying by 2. So I would continue that pattern and assume the next number is 32 new students. Now the number of students who know is 31 plus 32, so 63. All right, let's see another problem. Caroline is training for a swim meet. I realize, I want to just take a moment here to say, I realize that these 2 are not in your notes. It's because this is new and that you can do these with me, or you can just wait to finish your notes or to do your notes with me in the next 2 problems. But let's do this one more together. Caroline is training for a swim meet. The graph shows the number of laps per day that she swims this week. If she stays with this training pattern, how many laps per day will Caroline swim in week 8? It looks to me like we're talking about 2 things. We're talking about number of laps, and we're talking about number of weeks. So let's make a table. You can make a vertical table or a horizontal table. That's up to you. All right, so let's start off. At week 1, we can see that she has swum 1 lap per day. After week 2, she swims 3. After week 3, she swims 6. After week 4, she swims 10. Now I want to continue the pattern to find out where she's at on week 8. 5, 6, 7, 8. Now, I don't need to have the graph to figure this out. I need to find what the pattern is going from one number to the next. Let me change this color quick so it stands out. How did I get from 1 to 3? I added 2. How do I get from 3 to 6? I add 3. How do I get from 6 to 10? I add 4. I'm seeing a pattern. 2, 3, 4. I can assume the pattern continues, and the next number can be found by adding 5. And the next number in the sequence can be found by adding 6, then by adding 7, and then by adding 8. And so my final number is 36. So I would assume that at week 8, she would be swimming 36 laps. All right, this one is in your notes packet. Try to give this one a try. Each student on a committee of 5 students shakes hands with every other committee member. How many handshakes will there be in all? Make sure that you count the handshake between 2 people as one handshake, not one handshake for each. All right, pause the video, give it a try, and come on back. All right, so the pattern that I see is that we need to add new handshakes to the previous amount of handshakes. So each student will have, if I have 1 student, that student will have 4 handshakes because there's 5 students total, and if I'm the first student, I'm going to shake 4 hands. That's a total of 4 handshakes for me. Now I'm going to continue filling in the chart. Look at number 2. The second student I've already shaken hands with, so we're not going to count that handshake again. So that student is going to have 3 handshakes because they've already shaken hands with me. Now, the third person has already shaken hands with person 2 and person 1. So this person will have 2 handshakes. Person 4 has already shaken hands with person 3, person 2, and person 1. And so person 4 only needs to shake hands with person 5, having 1 handshake remaining. At this point, person 5 has already shaken hands with every single person. So they have 0 new handshakes. Now, to find the total number of handshakes that have taken place, we're going to go here. The first person had 4, and the second person had 3 new ones, so a total of 7. The next person 3 had 2 handshakes. Let's see if I can highlight that. And I need to add that to the 7 handshakes that have already happened. So that's a total of 9 total handshakes have taken place. The next student, person 4, had 1 handshake. I need to add that to the 9 handshakes that have already taken place, and I get 10 handshakes. Then 0 handshakes for person 5 plus the 10 is a total of 10 handshakes. Okay, let's give this one a try. You have a penny, a nickel, a dime, and a quarter. You give away 3 coins. How many different amounts of money can you give away? Name the values. All right, so there's penny, nickel, dime, and quarter. Pause the video and you try it one way and come on back and compare it to how I do it. Okay, so one thing you could do is give a penny, a nickel, and a dime. Another thing they could do is give a nickel, a dime, and a quarter. Another thing they could do is give a dime, a quarter, and a penny. And another thing they could do is give a quarter, a penny, and a nickel. Now let's find what that amount is. A penny is 1 cent, a nickel is 5 cents, a dime is 10 cents. That would be 16 cents. A nickel is 5 cents, a dime is 10 cents, a quarter is 25 cents. And so I get 40 cents. Right, the next one. A dime is 10 cents, a quarter is 25 cents, and a penny is 1 cent, 36 cents. And lastly, in all of the possible combinations, I see that a quarter is 25 cents, a nickel is 5 cents, a penny is 1 cent, so I end up with 31 cents. So now, how many different amounts of money can you give away? Here they are. Here are all the possible, I did it in an organized chart. Are there other tables? You bet. Let's compare our answer. And yes,